China unveils a $13 billion hypersonic aircraft that defies all known laws of physics. Welcome to the latest issue of Top Secret. China has just made a groundbreaking move that has sent shockwaves through the aviation world. Nanyang No. 1, a supersonic aircraft valued at up to $13 billion. Not only does it break all speed limits, it challenges even the most seemingly unshakable laws of physics. With the ability to take you from Beijing to New York in less than an hour. This machine promises to erase all distances. What breakthrough secrets does this advanced technological engine conceal? Could this be the turning point that transforms all of human civilization? Discover Indonesia No. 1. China amazed the entire world when it announced the Nanyang No. 1 project. A supersonic aircraft capable of reaching Mach 6. That means 6 times the speed of sound. To put it into perspective, the speed of sound is approximately 1,234 kilometers per hour. And the NANKYANG-1 missile can reach speeds of up to 7,400 kilometers per hour. At this speed, a flight from Beijing to New York would take only. Typically, this journey takes over 13 hours on common commercial flights. Less than an hour remains. This is not a far-fetched dream or a distant, fantastical idea. This is not merely an idea on paper, but a concrete project, born from years of meticulous research. The serious investment and thorough testing process from a team of leading scientists and engineers. The distinctive feature of Nanyang No. 1 isn't just its superior speed. Moreover, it is also reflected in the design, innovation, and pioneering technology. The engine of this vehicle model is equipped with the mutter system. Its full name is Monty Dark Test Twin Turbine Ejector Ramjet. A unique combination of multiple engine types ensures optimal performance at both low speeds and supersonic speeds. This system utilizes a turbofan engine, operating primarily during takeoff and landing. Helps the aircraft maintain stable operation at standard flight speeds. When needing to accelerate to break through the sound barrier, the jocket engine ignited, generating immense thrust that propelled the rocket to supersonic speed. Speed has made a remarkable leap forward, capable of maintaining a supersonic state throughout the flight. This combination allows the Nanyang No. 1 to transition smoothly between flight modes. To ensure all operations remain stable and achieve high efficiency. This is truly a significant leap forward compared to previous supersonic aircraft like the Concorde. With a maximum speed of only Mach 2, it is equivalent to 2,468 kilometers per hour. Project No. 1 in Nam Kayan, led by project manager Jin Zhang, an outstanding scientist at the China National Aero Engine Corporation. He and his colleagues began this research journey in 2019. To turn the idea on paper into reality, they had to face countless technical challenges. Jin Zhang asserted that the Nanyang No. 1 is not merely a means of transportation, but also represents a revolution in the global transportation sector. He believes this aircraft has the potential to revolutionize the way people connect, narrowing geographical distances and promoting exchanges between nations. With a weight of only 500 kilograms in its unmanned test version, the Nanyang No. 1 ship has demonstrated its ability to reach high speeds under test conditions. This project instills strong confidence in its feasibility. According to the plan, this aircraft will officially enter service starting in 2025. With a capacity for 10 passengers, this aircraft is ideally suited for charter flights in high-end business or all-inclusive tourism. The debut of the Nanyang No. 1 aircraft not only marks a significant milestone in the aviation industry, but also serves as a powerful testament to China's ambition and exceptional innovative capabilities. Opening a new era for the hyperspeed travel industry. What is hypersonic technology? Hypersonic technology, also known as hypersonics, is the field of research focused on vehicles capable of traveling at speeds above Mach 5. That means 5 times the speed of sound. At this speed, an airplane can travel thousands of kilometers in an astonishingly short amount of time, transforming long-haul flights that take dozens of hours into journeys lasting just a few hours. However, to achieve supersonic speeds, engineers must overcome a series of daunting physical and technical challenges. From managing the extreme heat generated by atmospheric friction to designing engines capable of efficient operation across diverse flight regimes. Every aspect demands absolute precision and exceptional creativity. These barriers not only challenge the intellect but also push the boundaries of modern technology to its absolute limit. The Nankiang No. 1, China's supersonic aircraft, stands as clear proof of its efforts to overcome these technical challenges. The aircraft is equipped with a highly complex engine system, integrating three main types of engines to ensure optimal performance throughout all phases of the flight. First, the turbofan engine, the most common type of engine on commercial aircraft, is primarily responsible for the low-speed takeoff and landing phases. As the aircraft began to accelerate, the rocket engine ignited, generating immense thrust that propelled it past the sound barrier and into the high-speed regime. Finally, the ramjet engine is designed to operate optimally at speeds above Mach 3, taking on the task of maintaining supersonic speed for the entire flight. A ramjet is a special type of jet engine that operates on the principle of using a high-speed airstream to compress and ignite fuel, thereby generating immense thrust without the need for complex moving parts. The integration of these three types of engines requires extremely sophisticated manufacturing techniques and perfectly synchronized coordination. This allows the aircraft to seamlessly transition between flight modes, ensuring both stability and optimal performance. One of the greatest challenges in the development of hypersonic technology is controlling the temperature. At Mach 6, the friction between the aircraft and the air generates an immense amount of heat, reaching up to 1,500 degrees Celsius, which far exceeds the melting point of common materials like steel or titanium. If not properly controlled, this level of heat could affect the aircraft's structure. To address this issue, Chinese engineers utilized Macan ceramic matrix composite, an advanced material renowned for its remarkable lightweight properties and exceptional heat resistance. These materials help protect the aircraft's surface from extreme temperatures but still require optimization to ensure long-term durability. The thermal protection system of Nankiang No. 1 is designed to dissipate heat passively, helping to reduce the surface temperature without the need for complex cooling systems. However, with long-duration flights, maintaining effective heat dissipation remains a major challenge. Heat is generated not only by external friction, but also by internal electronic systems such as flight controllers, positioning devices, and sensors. During operation, these devices emit a significant amount of heat, necessitating a modern cooling system to prevent malfunctions while in flight. The combination of heat-resistant materials and effective cooling technology is the key to ensuring the safe and reliable operation of Nankiang 1, paving the way for a new future in hypersonic travel. Core operations of Nankiang No. 1. To truly grasp the scale of the Nankiang No. 1, an effective approach is to compare it to Concorde, the legendary supersonic airliner that once dominated the skies from the 1970s until 2003. Concorde, a collaborative product between Britain and France, reached a maximum speed of up to Mach 2.04, equivalent to 2,179 km per hour, twice the speed of sound. Thanks to this speed, the ship could complete the journey from London to New York in just about 3.5 hours, a remarkable achievement for that time. The transatlantic journey, which typically takes over 7 hours on conventional flights, has now been significantly shortened, offering a completely novel travel experience. However, when placed next to the Nankiang No. 1, the Concorde appears to be merely an outdated and sluggish vessel, like an ancient machine beside a modern technological masterpiece. The Nankiang No. 1 has far surpassed its previous maximum speed record, reaching a top speed of up to Mach 6, 3 times faster, enabling it to complete a journey from London to New York in under 1 hour. This speed not only redefines the concept of air travel but also unlocks the potential to connect continents in a completely unprecedented way. If the space shuttle was once the symbol of speed, then the Nankiang No. 1 is a quantum leap, bringing the aviation industry closer to the dream of near-instantaneous travel. Technologically, the vessel utilized an improved turbofan engine, an advanced technology for its time, though it featured a simpler design compared to the engine of the Nankiang No. 1. Previously, aircraft were newly integrated with a hybrid propulsion system, consisting of turbofan engines, pulse jet engines, jockets, and ramjet engines. This combination not only enables higher speeds, but also improves fuel efficiency and enhances flexibility, allowing the Nankiang No. 1 to operate effectively in various flight conditions. However, the Concorde faced significant challenges. One of these was the tremendous noise from the sonic boom produced when it broke the sound barrier. This very issue led to it being banned from flying over land in many countries. This has significantly restricted the flight routes of the caught bird, primarily limiting them to transoceanic journeys. Despite being more advanced, the Nankiang No. 1 could not avoid a similar problem. Designers are striving to find noise reduction solutions to meet increasingly stringent international standards, which truly presents a significant challenge. Additionally, this railway line was also forced to cease operations in 2003 due to excessively high operating costs, continuously declining passenger demand, and concerns over its negative environmental impact. Number 1 Nankiang, despite being equipped with modern technology and having the potential to overcome these limitations, still faces numerous challenges such as high development and operational costs, along with extremely stringent environmental regulations. However, the advent of the Nankiang No. 1 ignited hope for a new era in the aviation industry. Supersonic travel is no longer a distant dream, but has become a sustainable reality, connecting the world in a faster and more efficient way than ever before. The global race to develop supersonic aircraft is intensifying and becoming increasingly fierce. Leading nations and technology corporations worldwide are competing to take the forefront in this highly promising field, marking a new chapter in aviation history. The launch of the C919, Nankiang No. 1, not only marks a monumental leap forward for China in the aviation industry but also serves as a powerful statement, challenging the world's leading aviation powers. The race to develop hypersonic technology is currently extremely vibrant, attracting the participation of numerous countries and private companies with ambitions to shape the future of aviation. In the United States, pioneering companies such as Hermeus, Straightlines, and Hypersonics are striving to develop groundbreaking hypersonic aircraft models. Hermeus is aiming to develop a passenger aircraft capable of reaching Mach 5 speeds, promising to significantly reduce travel time for intercontinental flights. Meanwhile, Straightlines is focusing on developing hypersonic satellite launch vehicles, opening up new opportunities for space access. The National Aeronautics and Space Administration, NASA, has also entered this race with its X-59 Quiet Supersonic Technology, KSST, project, which focuses on minimizing the sonic boom. From that point, civilian supersonic flights could operate over land without concern for violating noise regulations. Russia, a formidable competitor in the field of hypersonic weapons, has achieved impressive accomplishments, particularly in military applications. Russia's Avangard hypersonic missile can reach speeds of up to Mach 20, making it nearly impossible for current missile defense systems to intercept. The Kinzhal hypersonic missile is designed to be launched from fighter jets, reaching speeds of up to Mach 10, providing a significant strategic advantage on the battlefield. These advancements not only reinforce Russia's position but also raise concerns among military analysts about a shift in the power balance of modern warfare. Hypersonic technology has the potential to reshape the nature of warfare. Europe is also part of this race, as France has launched the VMAG project to develop advanced hypersonic aircraft and weapons. India is deploying an experimental hypersonic technology vehicle, an effort to develop a hypersonic missile aimed at enhancing its defense capabilities. While each country and region has its own approach, all clearly recognize the immense potential of hypersonic technology. Not only in the field of civil aviation, but also in the military and space exploration sectors. The Nankiang Project No. 1, with its impressive speed and advanced compound engine technology, is currently leading the trend, affirming China's pioneering position in this field. The fierce competition between nations and private companies not only drives technological innovation but also opens up the prospect of a future where time barriers are erased. And the space was significantly narrowed, benefiting both civil and military sectors on a global scale. Application and influence. Nankiang No. 1 is not merely an aircraft, it has become an icon of technological breakthrough, unlocking countless new opportunities across various fields. In the field of civil aviation, this technology has the potential to revolutionize the tourism industry and global business operations. A flight from Shanghai to Sydney normally takes over 10 hours, but will be shortened to less than 2 hours with the Nankiang No. 1. This superior speed not only saves time but also fosters connectivity between continents, creating favorable conditions for entrepreneurs, scientists, and tourists to travel quickly and easily. Furthermore, hypersonic technology could facilitate the high-speed transportation of goods ranging from medical equipment to high-value merchandise. It delivers significant economic benefits by reducing delivery times and improving logistics efficiency. In the military field, hypersonic technology creates a superior strategic advantage. Supersonic aircraft or missiles possess superior speed and excellent maneuverability. They possess the capability to penetrate modern defense systems, making interception nearly impossible. Although the Nankyang No. 1 was primarily designed for civilian purposes, its advanced technology could pave the way for military applications. For example, high-speed reconnaissance aircraft or strategic transport systems. These capabilities raise concerns about a new arms race. As nations compete to develop hypersonic weapons, the balance of power in modern warfare is shifting accordingly. Hypersonic technology unlocks tremendous potential for satellite launches and space exploration. Reusable hypersonic vehicles, such as those being developed by companies like Hypersonics. It can significantly reduce satellite launch costs, thereby promoting the development of the commercial space industry. The advanced engine system aboard the Nankyang ship No. 1 has the potential to become the foundation for future spacecraft. To help humanity advance further on its journey of cosmic exploration, from launching satellites into orbit at extremely low costs to supporting deep space exploration missions, Nankyang's No. 1 hypersonic technology is not only a breakthrough in the aviation industry, but also the key that unlocks a completely new era. A place where the boundaries of time and space are erased, benefiting both Earth and the cosmos. Despite promising prospects, hypersonic technology and the Nankyang No. 1 vessel still face significant challenges. To achieve maximum effectiveness, this issue demands breakthrough and innovative solutions. One of the biggest challenges is controlling the temperature. When traveling at Mach 6 speed, friction with the air generates temperatures of up to 2,500 degrees Celsius, which is sufficient to melt most common materials. Engineers have developed an advanced ceramic composite material along with a thermal protection system to reinforce and protect the aircraft fuselage. However, maintaining the effectiveness of these materials during long flights remains a major challenge. Excessive heat not only affects the exterior casing but also endangers the internal electronic systems. Modern cooling systems are mandatory requirements to prevent damage, ensure safety, and enhance the durability of aircraft. Cost is another barrier hindering the widespread adoption of hypersonic technology. The development of a prototype like Nankyang No. 1 cost billions of dollars, and the subsequent mass production process required even greater expenditure. Advanced materials, complex engines, and specialized manufacturing processes have significantly driven up costs. According to estimates, the ticket price for a supersonic flight could reach up to $100,000, making this mode of travel suitable only for a small group of wealthy passengers. Moreover, operating costs, including specialized fuel and complex maintenance, are also significantly higher compared to conventional aircraft. For supersonic technology to become widely accessible, manufacturers must find ways to reduce costs. Economic efficiency can be improved by reusing components or enhancing production technology. Sound waves generate noise, which also presents another major challenge to address. The Concorde was restricted from flying over land areas